The language in Article 3 Roman 2030 of the 2002 National Electrical Code, which specifies the secure fastening of conduit and raceway systems, does not explicitly mention the word fittings. However, it is generally understood that the intent of the requirement is to ensure that the conduit or raceway is securely fastened within a reasonable distance of its termination point, regardless of whether that termination is a box, cabinet, or fitting. Consider an example where there is a run of electrical metallic tubing, EMT conduit, that terminates near the bottom of a large panel board, but it is run along the length of the side of the equipment. While the language of NEC 3 Roman 2030 could potentially allow one to secure the conduit 3 feet above the panel, this would not be in accordance with the intent of the code. The purpose of the requirement to secure conduit within a certain distance of its termination is to prevent the conduit from becoming loose or falling down, which could damage the equipment or create a hazard. In this example, if the conduit were secured 3 feet above the panel, it would leave a substantial length of conduit unsupported, which could pose a risk. While the language of NEC 3 Roman 2030 may not explicitly mention fittings, it is generally accepted that the intent of the requirement is to ensure that conduit and raceways are securely fastened within a reasonable distance of their termination points, regardless of whether those terminations are boxes, cabinets, or fittings. In this example, it would not be compliant with the code to secure the conduit 3 feet above the panel board, as this would leave an unsupported section of conduit that could pose a hazard. In applying the National Electrical Code, NEC, it is crucial to understand the intent behind the rules, not just the literal wording. This is particularly important when dealing with sections like Article 3 Roman 2030 concerning the secure fastening of conduit and raceway systems. Let's delve deeper into the specifics of interpreting and applying this section of the NEC. A primary objective of Article 3 Roman 2030 is to ensure that conduit and raceway systems are installed in a manner that provides mechanical integrity and safety. This means that the conduit must be adequately supported to prevent it from becoming loose, sagging, or otherwise creating a hazard. The code mandates the conduit be securely fastened within a certain distance from termination points such as outlet boxes, junction boxes, device boxes, cabinets, conduit bodies, or other tubing terminations. While the code provides specific measurements for these distances, the underlying principle is to provide sufficient support to maintain the system's stability. When interpreting Article 3 Roman 2030, one must consider the practical implications of the installation. For example, consider a scenario where a run of EMT conduit is installed parallel to a large cabinet or panel board. The conduit terminates near the bottom of the panel, but runs along the length of the side of the equipment. According to the literal wording of the code, one might argue that securing the conduit 3 feet above the panel would be compliant, even if there is a significant length of unsupported conduit remaining to the actual termination. However, this interpretation would be inconsistent with the intent of the code. The intent is to ensure that the conduit is supported close enough to the termination point to prevent any potential strain or movement that could compromise the connection or create a hazard. In such a case, securing the conduit only at a point 3 feet above the panel would leave a substantial length of conduit unsupported, potentially leading to sagging or displacement. This could, in turn, strain the connection at the termination point and increase the risk of the conduit becoming dislodged or damaged. It is important to note that the NEC does not explicitly mention fittings in all instances within Article 3 Roman 2030. However, the absence of this term does not negate the requirement for proper support at or near fittings. Fittings are integral components of conduit systems, and they must be securely fastened to maintain the system's overall integrity. Whether it is a connector, coupling, or any other type of fitting, it should be supported in a manner that prevents stress on the fitting itself and the adjacent conduit. The NEC specifies different support requirements for different types of conduit and raceway systems. These requirements take into account factors such as the material of the conduit, its size, and the environment in which it is installed. For example, rigid metal conduit, RMC, typically requires less frequent support than EMT due to its greater strength and rigidity. Similarly, PVC conduit, which is more susceptible to sagging and deformation, may require more frequent support, especially in warmer environments. It is essential to consult the relevant tables and sections within the NEC to determine the specific support requirements for each type of conduit. These tables provide guidance on the maximum spacing between supports and the methods for securing the conduit. In addition to the specific support requirements outlined in the NEC, it is also crucial to consider industry best practices and manufacturer recommendations. These resources often provide valuable insights into proper installation techniques and can help to ensure that the conduit system is installed in a safe and reliable manner. For instance, manufacturers of conduit fittings may specify particular methods for securing the fittings to the conduit and to the supporting structure. Following these recommendations can help to prevent issues such as loose connections or damaged fittings. Furthermore, it is important to consider the environmental conditions in which the conduit system will be operating. In corrosive or harsh environments, additional measures may be necessary to protect the conduit and its supports from degradation. This could include using corrosion-resistant materials, applying protective coatings, or providing additional support to withstand the effects of wind, vibration, or other external forces. When inspecting a conduit installation, it is crucial to look beyond the surface and assess the overall quality of the workmanship. This includes verifying that the conduit is properly aligned, that all connections are tight and secure, and that the supports are adequate to prevent sagging or movement. Any signs of poor workmanship, such as loose connections, damaged conduit, or inadequate support, should be addressed immediately to prevent potential hazards. In conclusion, interpreting and applying Article 3 Roman 2030 of the NEC requires a thorough understanding of the code's intent, as well as practical knowledge of conduit installation techniques. While the literal wording of the code is important, it is equally important to consider the overall safety and reliability of the installation. By adhering to the principles of proper support and secure fastening, electrical professionals can ensure that conduit and raceway systems are installed in a manner that protects people and property from electrical hazards. Always refer to the latest edition of the NEC and consult with qualified professionals when in doubt. Securely fastening electrical conduit is a fundamental aspect of electrical installations, and adhering to the guidelines provided by the National Electrical Code (NEC) is paramount for ensuring safety and compliance. Article 3 Roman 2030 specifically addresses the requirements for securing and supporting various types of conduit and raceway systems. This section mandates that all conduit and raceway systems be securely fastened within a specified distance from termination points such as outlet boxes, junction boxes, device boxes, cabinets, conduit bodies, or other tubing terminations. The purpose of this requirement is to provide mechanical support to the conduit, preventing it from becoming loose, sagging, or otherwise creating a hazard. Different types of conduit have different support requirements, and the NEC outlines these variations in detail. For example, rigid metal conduit (RNC) generally requires less frequent support than electrical metallic tubing (EMT) due to its greater strength and rigidity. Intermediate metal conduit (IMC) falls somewhere in between RNC and ENT in terms of support requirements. PVC conduit, due to its flexibility and susceptibility to sagging, typically requires more frequent support, especially in warmer environments where it can become even more pliable. When installing conduit, it is essential to use appropriate fastening methods and hardware. This includes using conduit clamps, straps, and hangers that are specifically designed for the type and size of conduit being installed. The fasteners should be securely attached to the building structure using screws, bolts, or other approved methods. It is also important to ensure that the fasteners are properly spaced and aligned to provide adequate support along the entire length of the conduit run. In addition to the general requirements for securing conduit, the NEC also addresses specific situations and applications. For example, when conduit is installed in wet or damp locations, it must be supported in a manner that prevents water from accumulating inside the conduit. This may involve using watertight fittings and sealing the conduit ends to prevent moisture from entering the system. Similarly, when conduit is installed in areas subject to physical damage, it must be protected from impact or abrasion. This may involve using rigid conduit, encasing the conduit in concrete, or installing guards or barriers to prevent damage. When working with conduit systems, it is crucial to pay attention to detail and ensure that all connections are tight and secure. This includes properly tightening conduit couplings, connectors, and fittings to prevent loosening or separation. It is also important to use appropriate tools and techniques to avoid damaging the conduit or fittings during installation. Over-tightening connections can lead to stripped threads or cracked fittings, while under-tightening can result in loose connections and potential hazards. Another important consideration when securing conduit is the potential for thermal expansion and contraction. Conduit systems can expand and contract due to temperature changes, and this movement can put stress on the supports and connections. To accommodate thermal movement, expansion fittings may be required in long conduit runs. Expansion fittings allow the conduit to move freely without putting undue stress on the system. When installing conduit in areas subject to seismic activity, additional precautions must be taken to ensure that the system can withstand earthquakes. This may involve using flexible conduit connections, seismic bracing, or other methods to prevent the conduit from breaking or collapsing during an earthquake. It is important to consult local building codes and regulations to determine the specific seismic requirements for conduit installations in a particular area. In addition to the NEC, other industry standards and best practices can provide valuable guidance on securing conduit systems. For example, the National Electrical Manufacturers Association (NEMA) publishes standards for conduit fittings and supports, and these standards can help ensure that the products used in an installation are of high quality and suitable for the intended application. Furthermore, manufacturers of conduit systems often provide detailed installation instructions and recommendations, and following these guidelines can help ensure that the system is installed correctly and performs reliably. When inspecting a conduit installation, it is important to look for signs of poor workmanship or potential problems. This includes checking for loose connections, damaged conduit, inadequate support, and improper grounding. Any issues that are identified should be corrected promptly to prevent potential hazards. Regular maintenance and inspection of conduit systems can help to identify and address problems before they become serious. This may involve tightening connections, replacing damaged components, and ensuring that the supports are still in good condition. By taking proactive steps to maintain conduit systems, electrical professionals can help to ensure their long-term reliability and safety. In conclusion, securely fastening electrical conduit is a critical aspect of electrical installations, and adhering to the requirements of the NEC is essential for ensuring safety and compliance. By using appropriate fastening methods and hardware, paying attention to detail, and following industry best practices, electrical professionals can ensure that conduit systems are installed correctly and perform reliably. Regular maintenance and inspection can help to identify and address problems before they become serious, further enhancing the safety and reliability of the electrical system. Remember that specific requirements will vary based on the local electrical code and the specific installation environment, so always consult the latest edition of the NEC and local regulations for detailed guidance. Let's explore more about conduit support spacing, which is a vital aspect of electrical installations. The National Electrical Code (NEC) provides specific guidelines for the maximum spacing between supports for various types of conduit. These guidelines are essential for ensuring the mechanical integrity and safety of electrical systems. The NEC specifies different support spacing requirements for different types of conduit, taking into account factors such as the material of the conduit, its size, and the environment in which it is installed. For example, rigid metal conduit (RMC) typically requires less frequent support than electrical metallic tubing due to its greater strength and rigidity. Similarly, PVC conduit, which is more susceptible to sagging and deformation, may require more frequent support, especially in warmer environments. The support spacing requirements for conduit are typically expressed in terms of maximum distances between supports. For example, the NEC might specify that EMT must be supported at intervals not exceeding 10 feet, while RMC might be allowed to be supported at intervals up to 12 feet. These maximum spacing requirements are intended to prevent the conduit from sagging or becoming displaced, which could damage the wiring inside or create a safety hazard. In addition to the maximum spacing requirements, the NEC also specifies requirements for securing conduit at termination points and at intervals along straight runs. For example, conduit must be securely fastened within a certain distance of each outlet box, junction box, device box, cabinet, conduit body, or other tubing termination. This requirement ensures that the conduit is properly supported at these critical locations, preventing strain on the connections and reducing the risk of the conduit becoming dislodged. When determining the appropriate support spacing for a particular conduit installation, it is important to consider the specific conditions and requirements of the project. Factors such as the weight of the conduit, the type of wiring being installed, and the presence of any external loads or stresses can all affect the optimal support spacing. In some cases, it may be necessary to provide additional support beyond what is required by the NEC to ensure the long-term reliability and safety of the installation. It is also important to consider the type of supports being used when determining the support spacing. Different types of supports, such as conduit clamps, struts, and hangers, have different load-bearing capacities and may require different spacing intervals to provide adequate support. It is essential to select supports that are appropriate for the size and type of conduit being installed and to ensure that the supports are properly installed and secured. When installing conduit supports, it is important to follow the manufacturer's instructions and to use appropriate hardware and tools. The support should be securely fastened to the building structure using screws, bolts, or other approved methods. It is also important to ensure that the supports are properly aligned and spaced to provide uniform support along the entire length of the conduit run. In addition to the general requirements for conduit support spacing, the NEC also addresses specific situations and applications. For example, when conduit is installed in wet or damp locations, it must be supported in a manner that prevents water from accumulating inside the conduit. This may involve using watertight supports and sealing the conduit ends to prevent moisture from entering the system. Similarly, when conduit is installed in areas subject to physical damage, it must be protected from impact or abrasion. This may involve using rigid conduit, encasing the conduit in concrete, or installing guards or barriers to protect the conduit and its supports. When inspecting a conduit installation, it is important to check for proper support spacing and to ensure that the supports are securely fastened and in good condition. Any deficiencies that are identified should be corrected promptly to prevent potential hazards. Regular maintenance and inspection of conduit supports can help to identify and address problems before they become serious, ensuring the long-term reliability and safety of the electrical system. In conclusion, understanding and adhering to the NEC guidelines for conduit support spacing is essential for ensuring the mechanical integrity and safety of electrical installations. By considering the type of conduit, the specific conditions of the project, and the type of supports being used, electrical professionals can determine the appropriate support spacing and ensure that the conduit is properly supported. Regular maintenance and inspection can help to identify and address any potential problems, ensuring the long-term reliability and safety of the electrical system.